Hello, this is David, and in this video we're going to talk about considering a little bit more about probability and chance. We're going to talk about something called cumulative paired sales analysis, and that's basically when you use more than one or two pairs. We're going to also cover the law of large numbers, Monte Carlo simulations, and we're going to talk about an 80% significance level. All right, let's get started. This is where we ended up in the previous video. And we did the swimming pool. And we can see here this is one match pair. Now, we might say, well, one match pair can give us, some crazy answers. One match pair can give us some crazy answers. What if, because this is supposed to be 0% change in value and it's showing a minus 7.5. But what if you did 2 or 3 paired sales and averaged them? And here we're just going to be concerned with chance and randomness. Okay, what if we did that? Some people say if you have 30 sales, things tend to normalize out. In other words, you tend to lose maybe a minus when it's supposed to be 0% change in value over time. It gets rid of the minus 8% and the plus 8s and kind of brings it more in the middle. Well, we set up a spreadsheet, and I guess Mr. Numbers set up this spreadsheet. And let's take a look at what this spreadsheet does. In this spreadsheet, and he titled it Monte Carlo simulation. And what we're going to do is, we can see here we've got up to 30 sets of sales. See 30A and 30B, those two would be compared to each other. And then there is what it shows in a year, what their appreciation is. Now, we're concerned with maybe 3 sales. So let's go down to 3 sales and let's get to here. This is row 13. This is going to show the average of E8 through E13. So that's going to be the average from here to here. It's going to be 3. Remember, that's the return. So we have a sale and resale is 1 pair, a sale and resale is 2 pair, and then a sale and resale 3, A and B, that's 3 pair. And the first one came out 3.2, the second one came out 4.8, and the third one came out minus 8.4. Now this averages them, and the answer again is what it was before. The answer is 0, and look what it got. It got minus 0.01. I'm sorry. It's 0.1%. So it's very small. So it's almost 0. So this would have given us the right answer. Now, what we might look at, because what we'd like to know is what, not just this one time, but in general, what are the odds? Excuse me. What is the probability if I run 3 sets of paired sales in the same market over the same time period, and there's a randomness we set up here. It looks like it's already set from minus 8 to an 8, minus 8 to an 8% randomness in the market. What are the odds and what's the probability that I would get the right answer? Now, the first thing I want to do is stop right now and let's define what the right answer is. Let's say, because we've been looking at a range of answers from minus 8 to a plus 8, and we don't expect as appraisers things to be exact. So what I'm going to suggest is we say that if it's a plus or minus 2%, let's count it as the right answer. Because if we're doing in minus 8 and plus 8% variance in a market, let's just say that. So what we're saying is if we get an answer of 0, it would be correct. If it showed that the value changed over time up to 2%, it would be correct. So this is actually where it's wrong too. Anything above 2% is going to be wrong. Anything below minus 2% will be wrong. So I don't know if I've got that. You can stop the video, and of course you have the ability to replay it. But what we're saying is when is an answer right or wrong? We know the intrinsic answer is 0% appreciation, stable market, but we're going to allow for the data to fluctuate a little bit, and we're still going to call it right. So if it's as high as 2 above, as low as 2 below, we're going to count it the right answer. So this would have given us the correct answer. Now, what we're going to do is we're going to run this number here, 0.1. We're going to run this 25,000 times and see what the average of this is. Now, if you flip a coin and it's perfectly balanced, we always say it's a 50-50 chance of getting heads, a 50% chance of getting heads, okay, if it's perfectly balanced. Now, one way to test that out is to flip it like 5,000 times or maybe even 1,000 times. If you had a perfect flipper and you could flip it 1,000 times, now that's a lot of work. So what we've done with the computer is we've simulated that. And the name for this is Monte Carlo because it deals with probabilities. And so this is just the nickname for this simulation because it has to do with probabilities like gambling. And it is a simulation. It's set to run 25,000 times. So let's get it started while I'm talking. So what's happening here is it's randomly running these top 3. It's actually running them all, but we're only measuring the top 3 right here. The 3 pair of sales, and it's running it, and now at a plus or minus 8%, and we have 3 paired sales, we want to know what the probability is. And because we're going to now rely on a Monte Carlo simulation to apply the law of large numbers, we're going to get an answer. And I'm going to write this down. We got 68.6%, and that was at plus or minus 8%, and that was with 3 pairs. Okay, you see that? 68.6%. Now, that's the answer, and I think it was Carl in the book that asked the question, what if we had multiples and we averaged them? You know, at what point would it become reliable? Well, the probability under these situations, which is plus or minus 8%, and the correct answer is anywhere from 2, and you could have set it to be 1 to 2%, it would have done a lot worse. But maybe this is a lesson in real property markets. We don't want to get too precise. If it had said 2% or minus 2%, we might just round it to 0 in our appraisal reports now and say, no, we're just going to round this. No one knows because of, what's the magic word? Random variation or randomness. It really messes with us and all of these types of extraction techniques and finding values. Okay, so we got 68.6%. Okay, now I did a table, and I think it's in the book, and we came out in the book 68.7. When I ran it before, it came out 68.7. This time it came out 68.6. Now, so there's our table, and what we can see is the more randomness, the less for all of these. If you have one pair, the more random the market is, the less probability there is, you see. So with one pair of sales at plus or minus 5%, you only have 65% chance. Your odds are about 65.5% chance. At 10%, it gets worse. It's 58%, not much better than the flip of a coin. Now, so the more randomness, the less probability. So that's double trouble when you get into rural markets. Not only do you have less data, in a rural market, it's going to be more inefficient and it's going to have a wider variance. So that's why when you get into these rural markets, you have to be really careful when you rely on mathematical means of extracting your adjustment rates. Then you have to rely on some other types when you get into those markets. Now, the other thing to notice here is as you get more sales, you get more likely that you get the right answer. Look, if you could find 10 pair of sales, then you would be 90% chance of being correct. The average would be 90% chance. I'll buy that. Matter of fact, let's get on to the next thing. Let's talk about significance. When is this one single analysis, and I say single, it could be 10 or it could be two, but this one group of paired sales, not one paired sales, but this group, when do you buy it? And when you buy it as an appraiser, and when the user buys it, that's when it's significant, okay? That's when it's significant. Now, I've thrown out about 80% might be a good significance level when you're only looking at one method, maybe 80%. Now, you might say 60 and 60 if you have two independent methods. You might say, well, I have 60 in one, 60 in the other. So now I think that's a good significance level. But I don't really buy any of these singles. I don't buy 65%. That's just not enough. Now, two, man, it's close. You get two and you're in a good tight market of 5%, it's almost 80. So let's talk about what we've covered. We've talked about looking at multiple pairs of sales, and I didn't run it for anything but 3, but the table is where the others were run. They were all run by setting these and setting the and setting how many sales were involved. So we looked at that, and we can see that the more pairs of sales you analyze, the more significant it may become. We talked about the law of large numbers, and that is by running this scenario over and over again 25,000 times and averaging how many times it's right or wrong. And we defined right or wrong by the plus or minus 2%. We add those up, and by the law of large numbers, it will tell us the percentage. Now, the way we applied the law of large numbers, we did a Monte Carlo simulation. We basically hit this button, same as hitting this button 25,000 times. We would go bang, 1, 6, that's false, because we know it's got to be plus or minus 2. That's false. 4, false. 5, false. 6, false. I ain't getting one right yet. 7, false. 8, false. So we're all false there. We didn't get a single one in that run. So, but what we've done is, instead of trying to hit that 25,000 times and then add up the numbers the times you're right or wrong, Mr. Numbers set up what's called a Monte Carlo simulation. And when you hit this button, Excel uses macros. Now, a lot of people may wonder, and I get asked sometimes, why do you use Excel? There are free spreadsheets. I use Excel because I do more research. And even in my analysis, I like to program. I try to program, and Excel has a programming language called Visual Basic for applications. Now, the other thing we talked about then was a significance level, and I'm suggesting around 80%. Thank you.